Hello and welcome to part 2 of our study guide. Today we'll be picking up from number 11. So number 11 says, given the normal curve shown below, what percent of the population is represented from -2 to +2? So we're talking about this region right over here, from 2 standard deviations below the mean up until 2 standard deviations above the mean. And we're interested in the area under that curve, the shaded region. So the percent of the population represented from here to here is going to be found by simply adding up these 4 regions that make up our shaded area. So let's do the math. We need to add up 13.5% plus 34% plus 34% again plus 13.5 again. So I'm doing some mental math. That makes 68. These two combined gives me 27. And when I add these two together, I get 95. So 95% of the population is represented. Now, if it had said between -3 and +3, you would simply be adding this 2.35% once and twice for your final answer. Okay? All right, let's move to number 12. It says graph the function. Now, with graphs, it's super important to be aware of the mother function or the parent function. So in this case, since I see an x being squared, I realize that I'm graphing a quadratic. So this is going to have the shape of a parabola. And I know that because my parent function is y equals x squared. So if this is a parabola that's facing up, that's because there's a plus sign in the beginning, it's facing up. I have to ask myself, okay, what are these numbers doing to my graph? Well, this +1 inside is shifting us to the left 1 unit. And then this +3 on so shifting to the left. And then this +3 on the outside is shifting us up 3 units. So we've got our basic parabola, but it's being shifted to the left and being shifted up. That means that the vertex is really -1, 3. So we flip the inside to get the new vertex and keep the outside number. That's the shortcut, like mental shortcut that I like to use. Flip the inside, keep the outside. So let's graph this. We're at -1, which is actually right here, 3. So pay attention to the scale of this, these axes. And then we're a parabola facing up. So I'm going to go up 1 unit, over 1 unit, up 1 unit, back 1 unit, and draw as best as I can this parabola. Okay, so really quick, let's see if you feel comfortable. What would this graph look like? So if you're using our mental trick, our flip the inside, keep the outside, then you know the vertex is at +2, -1, and it's facing down. Okay, so again, we can do these relatively quickly just by knowing that I'm graphing a parabola. All right, number 13 says, find the domain and the range of this radical function. So in order to do that, first we're going to sketch a quick graph. Again, it's useful to know what the parent graph looks like. The square root of x is a graph that looks like a shooting star. It starts at 0, 0, and it goes over that way. And the reason for that, really quick, is if I were to plug in some numbers, if I plug in 1 into x, the square root of 1 is 1. If I plug in 4 into x here, the square root of 4 is 2. If I were to plug in 9 into x, the square root is 3. So we get this 1, 1. But then we have to go all the way to 4 to get the 2, and so on. So I like to call this the shooting star curve. Well, if we know that this is shaped like a shooting star, then it's so much easier to make our graph, because now we can just say, hey, what does that plus 4 on the inside do for us? So 2 ways of looking at it. You can think, oh, it's on the inside. That means it's being shifted left, right? And it says plus, but we always flip the inside. So it's being shifted left 4 units. Or you could think about the critical point here. Flip the inside, keep the outside. The critical point is going to be negative 4, 0, which makes sense because if I'm moving this back 4 units, then my new critical point is at negative 4, 0. So let's graph that. 1, 2, 3, 4, 2, 2, 2, 2, 2. And it's facing up. All right. So the question was more about the domain and range, but this is helpful for us. So the domain refers to all the x values that this graph takes. So if this would be x is at negative infinity and this is x is at positive infinity, our graph doesn't actually begin existing until negative 4, and it goes all the way till infinity. Or you could say x greater than or equal to negative 4. And now the range refers to all the y values. So to answer that question, we have to scan bottom to top. So our graph from the bottom, if this is negative infinity on the y-axis, and that's positive infinity, our graph doesn't actually begin existing until right here, right? Until y equals 0, and then it goes all the way till infinity. So we would say our range is from 0 till infinity, inclusive, because I do have a point at y equals 0. And you could say y greater than or equal to 0. Ta-da! All right. Let's go to number 14. So the instructions are easy enough. It says find the zeros. But what's a zero? A zero is another word for x-intercept, or the roots of a function. So anytime we're asked to find the x-intercepts, you should be thinking, like if you think about it graphically, anywhere that I'm on the x-axis, what do all of these points have in common? If you said their y value is equal to 0, then you'd be correct. Whenever we're dealing with x-intercepts, we set the y equal to 0. Or in this case, our y is actually represented as f of x, so we'll set f of x equal to 0 to find the x-intercepts. So let's set it equal to 0. Well, if this is my function, I'm setting it equal to 0 right now. And essentially, I'm going to solve for x. Well, this is a quadratic equation, so in order to solve, we will use factoring if possible. And if it's not possible, then as a last resort, we'll use the quadratic formula as a last resort. But first, we want to see if we can factor this. So in order, anytime we factor, we always want to check first if we can use GCF, or pull out a greatest common factor. Our second attempt, if there are 2 terms, will be to try difference of squares. And then finally, if there are 3 terms, we'll try magic x. Well, in this case, we're going to start, as always, at the top. Let's see if there's something we can factor out from each term. So I've got these 3 terms, and if you do some quick mental math or even use a calculator, you would recognize that we can actually pull out a 3 because 3 goes evenly into 3, 6, and 45. And anytime there's a negative in the front, I recommend to always, always, always pull out the negative. It will make our calculations easier later on. So let's pull out a negative 3 and very carefully see what we're left with. Anytime you pull out a negative, all your signs should flip. So negative 3 on the outside will leave us with x squared, and then plus 2x, and then minus 15. And you can check that. For example, negative 3 times negative 15, negative times a negative, leaves us with a positive value. All right, so now that we have checked off GCF, we have to work with magic X. We'll give it a shot anyway. So we see there are 3 terms in here. Let's see what we can do with them. So I'm going to need 2 terms that multiply to negative 15. I'll start my setup actually right away. I need 2 terms that will multiply to negative 15, but then add up to 2. So think about it. Pause the video. The numbers are 5 and negative 3. So since there's no number in front of this x squared, technically it's a 1, we can use our shortcut and just go x plus 5, x minus 3 equal to 0. Now finishing this off, we got kind of lucky here that this factored nicely. Now finishing this off, we'll set x plus 5 equal to 0, and we'll set x minus 3 equal to 0. We don't do anything with this number in front, it's just a constant. It doesn't make sense, after all, to say negative 3 equals 0. No, we're solving for x, so we'll only deal with the factors that include x. So subtracting 5 on both sides, x equals negative 5. And then over here we'll get x equals positive 3. And those are our answers. Now, let's say you were a little weaker in factoring. And you looked and you looked and you looked and you tried and tried and tried, and you're just like, oh gosh, for the life of me, I cannot factor this. Well, that's okay. That means that you would have had to try the quadratic formula. So if that's you and you're more comfortable with the quadratic formula, try it right now, because I'm going to show it to you worked out in just a second. Try it. Be very careful plugging in, and then see if you're getting. You should also get the same answers, negative 5 and positive 3. Here's the work. Pause the video if you haven't seen it yet. So for the quadratic formula, we're plugging into this equation. It's a negative b. So here our a would be negative 3, our b would be negative 6, and our c is 45. So in the beginning, negative b means negative negative 6. B squared will always turn positive here. And then you've just got to watch these signs of a negative times a negative, meaning that in the next step that turns into a positive value. Okay, simplifying all the way down, I would use a calculator to figure out that the square root of 576 is 24. And then we would break this into 2 different pieces. It says 6 plus or minus 24. So that means your 2 answers are 6 plus 24 on the left side, and then 6 minus 24 over negative 6 on the right side. And going down the line, you'll see that we did indeed end up with 2 answers that matched what we had earlier. Negative 5, positive 3. All right, let's go to number 15. Well, 15 and 16 go pretty hand in hand. This is asking us about measures of center and spread. In number 15, it says, what's most appropriate when we have a normally distributed spread of data? So a normal distribution means that there are no outliers. Whenever there's no outliers skewing our data, we will use the mean and the standard deviation. And so we calculate the mean by adding everything up and dividing by the number of things. And as far as this class goes, we don't actually make standard deviation calculations. Save that for statistics in college or AP Stats next year. But yeah, those are your answers. The mean and the standard deviation when it's normally distributed. So what if, on the other hand, now let's look at number 16. What if, on the other hand, we have a skew? A skewed distribution. It doesn't really matter which direction the skew is in, but that's what skewed right looks like. So an example of this real life is like household incomes. Because a skewed distribution, if we look at the x-axis being the incomes per year, let's say this is like $50,000 per year. This is $100,000 per year. Now we're talking $1 million per year. You'll see that the majority of households make in the lower end of the economic spectrum, and just very few households, very few, are making in the millions. So that means this is skewed right because we have some outliers. And so when we have outliers, we want to use measures of center and spread. We need to use measures of center and spread that are resistant to outliers. And those measures are, for center, the median, and for spread, the interquartile range. And those are our answers for number 15 and 16. All right, moving on to 17. 17 asks us to find cosine of theta given the two pieces of information. First, they're telling us that sine is -5/13. That's useful only if you know what to do with it. So first of all, when we see sine, cosine, tangent, they're giving us some ratio on the other side, immediately label that x, y, and r. So sine, my sine formula is y/r. And I'm writing it down right away because that'll help me label my sides later on. Okay, so that's piece of information number 1. Number 2, they're telling me theta is between pi and 3π/2. Well, pi is 180 degrees. 3π/2 is 270 degrees. So when it says that theta is in between them, what they're really telling me is, hey, you're going to be in quadrant 3. And with those two pieces of information now, we can actually create our triangle and then use that to find cosine. So let's do it. Let's piece this together. We're in quadrant 3, so draw your angle, and we always drop the perpendicular to the x-axis. Now this horizontal side here, that would be my x. This vertical side here, that would be my y. It's going up and down, just like y values go. And then this hypotenuse is r. So now we'll use the information right here. Our y value is -5. Our r is 13. And that makes sense, right? Because we're going down 5 units, right? If this was like my y-axis, it's in the negative direction. And then the hypotenuse is never negative, right? R is always positive. So using that information now, we've put everything we have. We need to find cosine theta. Well, cosine theta is nothing more than x/r. And check it out. We already have half of this thing solved. We already know that r is 13 because it's given. So now then we need to figure out what x is. we need to solve for this side. Well, since we're given two sides of this right triangle, we have to use the Pythagorean theorem to solve for the third side. So our Pythagorean theorem says x squared plus y squared equals r squared, and we're just going to plug in and solve for x. So plugging in what we know, y squared, that's -5. Well, I'm just going to put the number because we're talking about lengths here after all, equals 13 squared. So let's continue. Try solving it yourself. We want to get x all by itself. That means first we need to get x squared by itself. And in the last step, don't forget to take the square root of both sides to get x equal 12. Now, you might be thinking, yay, I got it right. But not so fast. The answer is not 12 over 13 because there's something key we're missing here. Yes, this distance is 12, but keep in mind we're going in the negative x direction. So that means x is actually equal to -12. So your answer should be -12 over 13. And I promise you that one of the distractors on your final is probably going to be the positive version of this. So I need you to pay attention to your quadrants and the signs of x and y. All right, so just to be clear, this would be the wrong answer. The correct answer is -12 over 13 because we put x over r for cosine. All right, let's move on to number 18. 18 says, hey, Miss Horning is counting sheep to fall asleep, and she counts these last week. Over the weekend, she counted 2 more. She counts 51 and 70. So what happened to the mean number of sheep and what happened to the median? So the mean is nothing more than the average. That means add up all numbers and then divide by the number of numbers. Let's deal with the mean first. So first we'll calculate, since this is what happened to the mean, this suggests that we need to find an original mean before the weekend, right, before those two added values, and then we'll find a new mean. Okay, so let's find the original mean first. To find the original mean, I'm going to be adding these all together. So 40 plus 47. Go ahead and use a calculator to add them quickly. So when I added these all up in my calculator, I got 194. Check me on that though. Okay, so that's the total. But to find so now we've added up all the numbers, but now we need to divide by how many we added. So we added together 1, 2, 3, 4, 5. So to find my mean, I will divide that number by 5. And 194 divided by 5 leaves me with 38.8. That's our original mean. On average, for the first 5 days, Miss Horning counted about 38.8 sheep per day. Okay, now let's find our new mean. So to find our new mean, we're going to add up now all of these numbers together. So 40 plus 47 plus 62, 30, and 15. As well as the 51 and the 70. So I already know that this adds up to 194 because we already did that math. So I'm just going to add on 51 and 70 for a total of 315. Check me on that. Don't trust me. actually do the math. And so then when we divide that, now we have to divide it not by 5, 1, 2, 3, 4, 5, but by 7, because we added 7 numbers total. And when I did the math, I got a new mean of 45. So to answer the question, what happened to the mean? Well, if we calculate the difference here, the mean rose by 6.2 sheep. Because it went from 38.8 to a new mean of 45. The next question says, what happened to the median? So we took some notes here on the mean. Let's take some notes on the median. The median is nothing more than the middle number when these are sorted. When the list is sorted, it doesn't matter which direction, lowest to highest or highest to lowest. But so that means that our first order of business then is going to be to sort these numbers. So let's find first the original median. I like to use black because it's easier to see. Okay, so our original median is, please don't jump and say 62. We've got to sort these. So 15 is the lowest number, then 30, then 40, okay? So our original median is just going to be the middle number here, which is 40. Easy enough? All right, now let's find the new median. So let's sort these again, but this time we're going to include these numbers at the end, 51 and 70. So my new list will be 15, 30, 40, 47, 51, 62, and then 70. Our middle number is 47. So to answer the question, what happened to the median? Our median rose by 7 sheep. And there you have it, the answer to number 18. All right, let's move on to number 19. 19 says, given this graph of cosine, what are the period and the amplitude of the function? So first, let's define some key terms. The period is the length it takes, or the distance, calculated by looking at the x-axis for one complete cycle. Basically, how long does it take for this thing to repeat itself once? So the way I like to calculate the period is always to start at 0. So see where the graph is at 0. It's up here. Now let's see how long it takes to reach its original starting point. So from 0 until 2 pi, our graph went like this, and now it's back at its original starting point. That's one complete cycle. Because if I were to repeat that, I continue on with my curve. So I know I calculated that correct. That's the right distance. So from 0 to 2 pi, the distance is 2 pi. That's one period. Okay, next question says, what's the amplitude? The amplitude basically refers to kind of like the height of this curve from the midline. I'm going to call that the midline because, right, our curve goes above and below, but that's kind of where it's centered at. So how high does it go? Height from the midline. So how high does this curve go from our midline? Well, we're talking about height, so we're definitely talking about the y-axis. It goes from 0 until whatever that number is. So if this is 5, 1, 2, 3, 4, 5, then we're counting by ones here. So our amplitude is simply 3. And however high you go in the positive direction will also be the same distance in the negative direction. You can just verify 1, 2, 3 as well. Great. So pretty straightforward. Just count from the graph. Okay, we're on our last question. It says, identify the angle on the unit circle where cosine is equal to root 2 over 2 and sine is equal to negative root 2 over 2. So you can use your unit circle. I'm going to think through this without the unit circle though. So first thing to note is whenever we see this number root 2 over 2, you should immediately associate that with one of the big three, and that would specifically refer to 45 degrees. And that makes sense that our cosine and sine should be the same because we're talking about a 45, 90 after all. Okay, so we know that this is a 45 degree reference angle, but now we need to know which quadrant because it could be 45. If it's in quadrant 2, it'd be 135, 225, or 315. So which angle is it? Well, that's where these signs come in. Our cosine is positive, but our sine of this angle is negative. So let's think about where cosine is positive and sine is negative. So I'm going to first start with where cosine is positive. Cosine is positive in quadrants 1 and quadrant 4. Because this tells me where the trig functions are positive. So all of them, sine, cosine, tangent, are positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent in quadrant 3, and so on. So if I need to know where cosine is positive, I can basically narrow this down to quadrants 1 and 2. And then I need to know where sine is negative. Well, it can't be in quadrant 1 because all of them are positive in quadrant 1. I need to know where sine's negative. So that tells me we're going to be in quadrant 4. Now the other way to figure that out, without using this trick of all students take calculus, is to think about what cosine and sine represent. Cosine is x over r, and sine is y over r. If cosine is positive, that means that my x has got to be positive because r is always positive, correct? So if cosine is positive, that means I need x to be positive, and if sine is negative, that means I need y to be negative. So where is x positive? It's in that direction. So either these two quadrants. And then where is y negative? Well, y is negative in this direction. So again, we end up in quadrant 4 either way. So now we can answer the question. We know that we are a 45 degree reference angle in the 4th quadrant. So our angle from 0 degrees is actually 315. The other way to answer this in radians would be 7 pi over 4. And those are your two answer choices. Okay, I hope you found this review helpful. I wish you the best of luck on your final.